Quick time play. Hey guys, welcome to the jungle. High entropy, I mean. And first of all, happy Independence Day to all of you. And it's a new, what we say? It's a new topic, or you can say new, basically tool that we are learning. It's a Snowflake. So I'll give you a quick overview about it, so that if you are completely new, you aren't aware about it, then I will tell you fundamentals and why I'm learning Cortex and what is reasoning behind it. I will tell you everything. And I'm here just learning Cortex part because nowadays AI is booming everywhere, so it's very important to know. If you have little experience on some tool, then you should have also know what are the AI capabilities in that tool. So I'll give you a simple overview, because the cool thing is, like, when I'm giving you when I will give you overview, I'll get to know what are the weaknesses and where I need to focus on, what are the things that are still I'm weak in those concepts, so I can revise them. And do let me know your opinion, comments, or whatever you are doing, and in the comment section you can say me your thoughts. So let me share my screen, and let's start with what exactly is a Snowflake if you are completely beginner or you don't know. And I'll just give you basic overview, architecture, and then we'll jump into the Cortex, how it plays a key role in the Snowflake. Snowflake. Sorry. Okay, so our topic is Snowflake. So I'll give you little background, what exactly and where it fits. So before Snowflake, I will just tell you what exactly is data engineering. I will tell you the core concept. Most of the data engineers, what they do. So before data engineering, so in data engineering, what data engineers do. So suppose, like, you are running an e-commerce business. So this is your business. There is a person who log 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 in into a system and see whether they which product they're performing good, which one is performing bad, and all you are getting. Or maybe business users, let's say. Okay, so just think, like, you will see, like, there are lots of dashboards and where they are analyzing and business users taking decision accordingly. For example, I remember few days back only I visited um, a restaurant, and the girl was telling that they are about to remove few of the products from there, but it is a small example. But in real life, when we come to know, for example, you can take example of any business. They make decision based on the performance. If someone is not if some product if a product is not performing good, or people are giving a lot of complaints, maybe they will deprecate the product and they will launch new product with uh, better capability and all. So they do it a lot of time. And what they do, so simply they build an analytical system where they get the insights da- from data. So this is the use case, like what they do and how it is happening, that we will see here in this part, that we do data engineering. So what normally, whenever you are building, so suppose you are a software engineer. Okay, you are software engineer. So what do you do? You build an application. Let's say you build a website, okay, for an e-commerce. So you build a website. This is a your website, and there is some database that is connected, and there you are storing data. For example, it could be products. There are different tables. If you know a little bit of database, so you will create different tables. I'm keep okay. Okay, let's continue. So you have product, you have customers, where you are keeping profiles of the customers and other sales maybe, and etc. There are also some tables. So you are keeping here. These tables are highly normalized. Normalized in the sense, if you are updating in a one place, you don't need to update multiple places. It's like you are normalized data. Normally, if you know little database concept, then Actually, I'm getting out of topic. I have to discuss something else. I'm discussing something else. So normalized data. That means you are trying to minimize the duplication, data duplication. Imagine, because when you come to databases, there is limitation of data storage, are very limited, and it's very costly also. So that's why the database designer are very concerned about the data duplication and all. Also, when you are updating, suppose there is a record about a person and it is being written into multiple registers, so there are chances like you will forgot to update, or maybe you have to update it multiple times. So these are the hectic works, right? In if you are talking in terms of simple, let's say example of uh, you are like a clerk or whatever we say, and you are just you have to update multiple register. But what if you are updating in a one place and it will be updated everywhere where they will refer that lookup? So that's why you are storing, whenever you are storing data here, you are storing uh, very highly normalized data, and there are normal form 1NF, 2NF, 3NF, and so on. So this is normal business that is running. So we call, so here basically you are performing CRUD operations, create, read, update, delete, okay, and everything is running smooth. But now they came up with requirement that they want to build the dashboard on top of this data. Okay, so they came up with like a business user came up and they want to build dashboard on top of it. Now what will be the problem? I will tell you, like suppose you build the dashboard. First thing, you have to combine multiple data set here. For example, it could be like you want to build a report where which product is performing well and how many customers are purchasing that product every month and so on. There are multiple business uh, KPIs, key point indicator, key performance indicator, I believe. So they are doing it. Now you have to join multiple tables, and join is a costly operation. It takes time, and you are performing in the same database where your business is running. So what will be the complexity here? First example, suppose someone is already busy in doing other tasks and now you have given overburden. There are high chances of failure, or maybe your business will be impacted and all. So you don't want, whenever you are, because these operations definitely is normally what you do when you are running business, just you are performing like, okay, read something from it and update something on the system. You are not performing any like, okay, join multiple tables and then get the insights and all. So it's a simple process when you are running this. But when you will give another load of analysis on the same database, the database uh, will be having overburden, and there are high chances of like a error will occur and all, or maybe it will become slow, because there is a limitation in the RAM, right? There is a limitation in the memory, and there is everything limited. Even if you think in simple human terms, like suppose I'll give you one example, cool example. Nowadays there are government teachers, right? And their primary job is to teach the student. But what government do, they give extra burden of some other works. For example, nowadays consensus, or what we say, census and all is going on, and because of that they have to go to villages and people's home, and they have to ask jangarna, we say. So they will go. So that's why they will, if you they will do other work, their performance will decrease in terms of teaching. So same happens if database is designed for running business and you are giving it to perform analysis as well, then there will be definitely overburden, right? So that's where a warehouse comes into picture. Okay, so this is warehouse. I don't know why I'm drawing it like this. Warehouse, let's say this is warehouse. Okay, so what you do, so simply instead of performing the data analysis here, you dump data from here to somewhere else. I'm so sorry if you are hearing the noise, um, because there is construction going on. and because of that you might hear a lot of noise. Okay, so what they do simply, this is our database, and now you are not running the business analytics on it. Instead of that, you dump the data into warehouse, and on top of it you will perform data analysis. Okay, I think that is okay. So now how you will dump? Definitely, business is running, so definitely there will be new changes will come arrive every day. So what you do simply, this is known as ETL or ETL or ELT. Nowadays it is very famous, ETL and ELT, and this is the main thing that most of the time data engineers do. So what they do simply, you schedule data extraction from here and loading it into here. So you do it at a scheduled time. Maybe I'm just giving you overview like how Snowflake fit into it. So at a scheduled time, maybe when business is very low, maybe suppose it is running in India, then and in the night there are highly chances like businesses uh, either not running. For example, if we take example of banking, then most of the transaction are doing in the daytime, and now there's forget about UPI. If we talk about normal banking transaction, so what they do simply, when the business is very low or when the database is having very low load, it is running at very low capacity load, then you do, yeah, what you do simply, you extract the newly data into data warehouse and you dump it. And on top of that, once new data arrives, you build the dashboards and they refresh at an interval. So this is a picture of data warehouse, how it fits and what is the use of ETL. ETL means extract, transform and load. So if you want to perform some transformation, that you do, and ELT means first extract, then load it in here, load it into data warehouse, and then perform transformation on top of it. Okay, now what is Snowflake here? So if I will tell you simply Snowflake, so you can say it's a data warehouse. Very simply, if I'm telling you this data warehouse where you are dumping the data, but that is not the real Snowflake. Snowflake has lot more capability than just a traditional data warehouse. That's why it is known as, we call different term, data cloud native data product, or what we say cloud native. Why? Because okay, let's talk about it. So I will give you, maybe I'll just give you simple and simple theory what exactly here we are doing. Maybe I don't remember what is Snowflake. Fuck. Data platform we say it. Because what do you do simply, I'll tell you, data warehouse or you can say data platform. So first thing is, it is known as cloud native. Why? Because it is completely running on cloud. You don't have to install a tool and you have to locally set up like other databases and all. Simply, you have to purchase subscription and you can choose the popular cloud where you want to deploy. For example, it could be AWS, that is very famous, Azure, or you can say GCP, Google Cloud Platform, and you have to deploy, and it will run on top of it. So what exactly it is doing? First thing, you can think of like a data where Snowflake. Simply, you will store data. Okay, you will perform computation on it. For that, you don't need any other tool or something. That basically you can run the query on top of it. You can perform complex analysis within the data warehouse. It's not like just database. You can perform the queries and all. Everything can be done here only. Now you might be thinking, okay, we can, like when we are running uh, a database in our local system we are installing, then we can also do that. But there your computer is playing key role, and there you are performing computation. So same thing is happening here. You can think of like computer, and what exactly you are doing. So database, you can think big warehouse where you are keeping the data, and here you are also performing analysis on top of it. So everything is running on cloud first thing. Okay. Second thing, now if we talk about the Snowflake architecture, how it works. So Snowflake plays a key role. What is the use of Snowflake here, if you think? So I will tell you. So basically it is divided into three layers. Snowflake, you can think of, everything is divided into three layers. Storage, you can think a big data lake where you are storing the data. Another thing, you can say a warehouse or virtual warehouse, and this is cloud service layer. What exactly these are? So like you have, let's say, Azure cloud. So storage, you can think of Azure data lake. So your data will be stored in the AWS. Virtual warehouse, you can think of like EC2 instances. uh, you can say uh, virtual compute, what we say, virtual box. I mean, yeah, I don't know, let's say, I forgot the name. Okay, okay, I got it. One more. Sorry. It is Azure virtual machine. I'm just telling you analogy how it is working. And cloud service layer, you can say this is a brain. Why we call it brain? Because this is the only thing that is where cloud Snowflake plays a key role. Otherwise, you can say, okay, I can do it. I can directly I can deploy warehouse, and I can use the storage, and I can store the data. But the main part is this brain that is going to coordinate with these virtual warehouse that will be used for compute purpose, where you will run the queries. This will be for storage purpose. Okay, and this cloud service layer. So whenever you hit a query, what happens? This cloud service layer, or its brain, you can say, is going to process your query. It's going to check whether you are a right person to run the query, and authentication, authorization, query optimization, so that it won't consume lot of credits and all. So everything is taken care by cloud service layer, and that plays key role. Otherwise it's simply you have virtual machines and where, and main thing is like how you are optimizing, and that is taken care by Snowflake. So, and that's what the Snowflake is. And now I'm learning Cortex. So this is normally traditional, but nowadays, as you know, AI is booming. So everyone or every platform, data platform or any other tool, they are integrating AI everywhere. So here, what exactly Cortex is? Cortex. So we got, I have given you basic overview. If you are watching, or if you never worked on Snowflake, then I given the basic overview. Snowflake Cortex. So I will tell you simple scenario what I was thinking about Cortex. I thought it's something that is cool thing, and it's going to do something different. It might be LLM model or something they built, but no, they are calling Cortex, and it is set of tools. Tools or capabilities, you can say. and they call them Snowflake Cortex. What are these capabilities? I'm just giving you overview what I learned from ChatGPT and all, and then we are going to grind, because there are a lot of things that needs to be learned, and we are going to learn them along. If you wanted, you can learn along with me. By the way, so Cortex set off are a suite of tools. So for example, they have given different tools based on the requirement. Suppose suppose you have a table, and there is some column where you kept something. Let's imagine let's say there is a e-commerce table where each product is there, and there are lot of reviews about the product, and now you want to summarize or you want to analyze the review of the product. So what you will do? Simply, the Snowflake provides AI functions that you can use in the Snowflake as a SQL. You can call them as SQL, and you can run. For example, if you are aware of the database queries, let's say select review from product. This is our query. Now you want to check whether the review is positive. Feed sentiment analysis you wanted to do. So they are exposing some Snowflake AI functions that you can utilize here itself. So review, and maybe you just want to get the feedback. So maybe there I'm not sure if it is AI sentiment. I believe sentiment. This is the function, and there you will pass review, and it will read the review. It's similar to you are calling the LLM functions only. Basically, they are behind the scene. It's going to call LLM, and it's going to return the result, and then you will get whether it's positive. It will give some number. Let's say 0 to -1 to 1. If it is 1, then it's a very positive review. 0 means neutral, or if it is in between, then also you can consider neutral. Maybe let till 0.5 or -0.5 you are considering neutral. So in such a way, basically this is one capability that they have given. If you want to perform some analysis, or you want to run some SQL function, uh, AI functions inside your query, then you can run them. And if I'm not wrong, AI sentiment, AI complete, there is a function, and let's learn them, because now learning starts. So what I'll do simply, so these are Snowflake AI functions. Okay, so before I was just giving a overview. Sorry. So first thing is in the Cortex Snowflake, there are some AI functions. Correct? That you got it. Different functions for different capability. These are LLM functions that's going to run behind the scene LLM, and they are going to give you output. So if I have to design a LLM function, so then what you'll do? So let's say complete, and you will call behind the scene when you are passing an input. It will call a function, and it will call LLM function behind the scene. Maybe we are calling Anthropic or any API tool. Okay, and then it will return response, and then you are going to return this response, and it will be part of the query. Okay, so this is how we are going to design it. If we have to design. Second thing, so this is a basic part that you can do. You can run in queries. Okay, use it in queries. And second thing is very important. If you have structured data, let's say there are some tables, and you ask Snowflake, I want uh, last 3 months sales, and give me by products. So you want 3 months sales. Now you will give it to Snowflake, and it will return you response, or you can say query and response. Okay. So this part here you are using structured data, And on top of that, maybe you are a business user. I remember one of business user, or maybe few weeks ago, I have seen that he was using the Cortex for the query preparation and all. So that's where you will call this, we call it Snowflake analyst. This is another capability. First one was Snowflake AI function, second is Snowflake analyst. And you will ask simply, okay, I want this. So basically you are giving what we say NLP. You are giving natural language as an input, and it will give you query, okay, and as well as you can say result if you want. So this is the, so okay, let's draw a simple diagram here. This is our Snowflake analyst. You have given NLP, natural language input, similar to chat gpt, you can say, where you are giving some input and it prepares query. I remember I even I mean 4 to 5 months ago I built one website using the chat gpt completely. I haven't used any complete tool, for example Codex or Claude, Claude desktop or something. I simply asked chat gpt give me, I was giving prompt like, okay, I want to build this feature. So that website was horrible, but it worked. And I just, my role was to integrate everything, and I was asking generate the query for that. So you can think in similar terms, in simple term I can say, just you are giving natural language input and it is going to pass it to LLM, you can think, or somewhere. Yeah, definitely behind the scene LLM is are going to take care of it. And so forget about LLM. So this is already part of it, and it will return, not here, I'll say here only, query and result. So you will get query and result. So this is the role of, I mean, so sorry, somehow this middle icon is not flashing away. Oh bro, what's wrong with it? Yeah. So here, so you are giving natural language input, you are getting response from it. So this is a Snowflake analyst. Then another tool similar to, not similar to, but first one was under the Cortex AI functions analyst, Snowflake analyst. This is second one, and it works on structured data. Okay, we'll talk more about it. Third one is, imagine you have unstructured data, you have some files and all, and you want to query about the files, or you wanted to query on files and you want to get the response from it. So maybe let's say you have given some company documents, and these are, let's say PDF you given, image you have given image and all other documents, and now you want to query and get response. Okay, so what do you do? Simply you will, this is known as Snowflake search. What exactly you do? So you will get response from it. So it's more of like retrieval augmentation generation, where what do you exactly do? You get data from it, and then you, what you do, simply whatever the data that you are getting, that chunk that is important, you are passing it to LLM, and that is known as augmentation, where you prompt plus uh, these docs chunk that you got, you are passing, and it will generate more accurate response according to it. So these are the three tools, and there are some other capabilities that we call, that are part of these main broader tools. AI agent, they have introduced, and AI workspace, I believe. But these are main Snowflake. So here you are basically using unstructured data. So for the time being, so if I have to summarize these three tools, first one is under the Cortex, Snowflake AI function. Second one is Snowflake analyst. Third is Snowflake search. So this is what my understanding is so far, and we need to deep dive into these. And this one is very simple. You can earlier I used to think, okay, Snowflake is just providing some LLM function and you can call, you can use. But this part is very cool part. Snowflake search is also very important. Um, but before that, Snowflake analyst, what happens? There are some semantic models that they have introduced. Basically, you can say if you have learned about MCP, I know basics of MCP. Normally, what whenever you are calling something, it gives you more context, and for LLM, context is very important. Whenever you are asking a question, and if you are giving some references, like, okay, just I will give you an example. Suppose I just said I want to generate a YouTube thumbnail. Okay, no, not in such a way. I said I wanted to learn the Snowflake Cortex and want to stream it on YouTube. Could you please provide me a can you generate a thumbnail, use this picture, and you are having 10 years of experience. That system prompts you are giving, like, okay, you are a professional thumbnail designer or graphics designer. So come up with an idea. That is known as prompt engineering, where you are giving more context to it. Otherwise, you can say generate a thumbnail for YouTube stream. No, you can say simply generate a Snowflake Cortex uh, thumbnail for YouTube streaming, live streaming, and it will generate something bogus. I'm not bogus, but it will generate some random thumbnail, and you might not. That's why fine tuning and all is very important, because they are blunt without context. Until you won't give context, they will give you some dummy response. For example, some of the questions are very easy. What is the capital of India? You don't need to ask, okay, I'm living in India, and India is a very beautiful country. There are 29, 30, 48 states. Sorry, so sorry. There are 29 states, and there are variety of cultures, religions, and could you please provide me the capital of India? You don't need to give all the information, because it's a straightforward question, and LLM is has been already trained on it, and they can give directly yes no response or even quick response. So it's up to us how we are tracking prompt engineering. By the way, let me drink water and let's begin. Okay, so first let me, what is Snowflake Codex? You can see here documentation is very good. They have given build query and reason inside the perimeter. Inside the perimeter, your data already trust. Snowflake Coco, formerly Cortex code. Snowflake Cowork. I was talking about the Snowflake AI functions, Cortex Analyst, large language model. This is very important. Use AI to accurately convert natural language to SQL. Simple to use. Simple to use, cost efficient to scale. Cortex enlist augment with. I don't know why are they not giving us these te- these things in the normal. So what I'll do, first thing is we need to learn. I will make a proper plan, then only it will succeed. Otherwise, I will be okay. Snowflake Cortex shared GPT. Snowflake. I want to master Snowflake Cortex. Could you could you please give me a structured roadmap for it? Let's do one thing. I kept one Snowflake account, so if you are new, but we won't be able to use it to be honest, because we can do Snowflake other capabilities, but when it comes to AI part, they are not providing it in the AI in the trial version. Very bad. I thought they will provide, but nah. So this is the Snowflake interface. You can see for 24 days, and very cool thing is like every time you can register after 30 days, you can re-register with the same email. You don't need to create another email. So this is cool thing that they are giving in the Snowflake. So shout out to Snowflake because still they are giving opportunity to learn. So every time you can use trial version for free without with the same email. I have used it so many times. So wonderful. And my network is slow. I what? Now I need to go to. Okay, let's. If your goal is to master Snowflake Cortex, I would not recommend learning it as a collection of AI function. You should learn in it as an AI engineering stack built on top of Snowflake. Snowflake's current Cortex system spans AI functions, AI SQL, Cortex search, Cortex analyst, Cortex agents, REST APIs, fine-tuning, and newer capabilities such as analytical search and AI function studio. Given that you are a data engineer, I would fuck don't reveal my information. Add structure your learning around building real AI data pipelines rather than becoming ML researchers. Cortex Mastery Roadmap. Think of the roadmap as Snowflake, AI LLM fundamentals, Cortex AI functions, RAG search, Cortex Enlist, Ascent production advanced. Phase 0 foundation, 3 to 5 days before micropartition. I know all these things. This one I need to work on. Snowpark basics I know don't know. Dynamic tables I know basic. Streams and tasks. Streams is used for change data capture. Okay, let's forget about it. Cortex specific foundation. Pay particular attention to structured data, Snowflake SQL, Cortex AI application. Phase 1 LLM fundamentals, 3 to 4 days. LLMs, okay, let me see what are the things that I know. So you don't need to become an ML engineer. You need enough LLM knowledge to understand what Cortex is actually doing. LLMs, I know LLMs basically these are big transformers that produce predict a new word, a token you can say each time when you give, and that's why it's like whenever you are giving an input and it starts predicting and it starts producing. I used to think like it's a cool animation only in the past, so it predicts. Okay, tokens are basically whatever the information or prompt that you are giving, it's going to be break into tokens, and that's how, and then those tokens are going to be converted into numbers that we call vectors. So context window, so there is a limitation how much information you can store in a context, like whenever you are giving prompt and all. So there is a limitation. Temperature, it depends on the randomness, whether if you'll keep more random, then it will come out of box and it will give some cool or maybe cool things, but otherwise it will give you uh, very structured output. Prompting, like you are giving input to the LM and techniques. For example, uh, it's a normal prompt that you are giving, question answer prompt, where you just say, are you AI robot or something, just response in yes or no or something. That, or maybe you can give other kind of information. I'm just going out of topic. Prompting basically are there are few short, one shot, few short, where you are giving some examples along with the prompt. For example, you can say, this is my input and give me a structured output. Here are few examples of output. System versus user prompt. Yes, this one also I know. System prompts, if you remember, I few minutes back only I talked, few minutes ago I talked about it. That, imagine, you are generating a thumbnail. You wanted to generate you wanted ChatGPT to generate a thumbnail. For that, what you will do, you will simply say you are a professional uh, thumbnail designer or graphic designer having 5 years of experience and think in that way. So that is system prompt. Basically, you are giving a context what exactly it is. That is system prompt. And user prompts, other than that, the information that you are giving, I need uh, roadmap or something. And here, suppose here for this, I just click, I have written like, I want to master Snowflake Cortex, could you please give me a structured roadmap for it. I haven't given any system prompt, but imagine I have given it like, you are a experienced data engineer, having 20 years of experience, 10 years of experience in the data engineering field, and you are designing a structured plan for that upcomer data, for new data engineers or for data engineers with less experience. How would you design? And then you are giving a system prompt. You are data engineer and all other stuff. Okay, so this is system prompts, user prompts. Embeddings, basically very important part. Embeddings means where you are converting tokens or any text into vector. So into vector, that is known as embeddings. And in the Snowflake, it provides a function AI embed, AI underscore embed. And here you are giving a model that you are using, dimensions that you are using. For example, AI embed, I think 768 and 1024, there are two functions basically that defines number of dimensions, vector dimensions. So input, model name you are providing, and the input that you are giving, that is going to be converted. And one more thing I forgot to tell. I When I started learning Cortex, I thought, well, let me ask if Snowflake has created its own LLM function. So Snowflake created two LLM functions. One is Snowflake LLM, another one is for specifically designed for embedding. So that's why here you can say they call it Snowflake Arctic. So this is embedding model. This is also embedding model. Snowflake Arctic embedding model. These are the different. Or you can use some other open source model or any other model that you wanted to use. It depends. And hey, you are giving text, convert hello world into vector, and it will convert. Even you can use AI embed, because they are calling it as multi-model. Multi-model means not only text, it can handle other kind of input, prompt, not prompt. So here you can say this is an image that you are giving as a prompt to file, and it will convert it into a vector. So when, by the way, where is the roadmap? So this is vector embeddings, vector similarity. What do you do when you create an embedding? Suppose this is one thing. Dog and puppy, you use two words. So for dog there will be vector, for puppy there will be vector. Now when we'll compare, like if you'll compare normally, then you will say, okay, dog and puppy looks different words and it should be different. Dog and other canine animal. So what do you do? Simply, let's say, okay, so what you will do here, if you are converting it into embeddings, then you can easily check in the vector space whether they are closer to each other or they are far away. If they are closer to each other, they have similarity. That's why they are near to each other. That is known as the The this is known as vector similarity. There we use cosine similarity and other, I don't remember. Semantic search, this is I don't know if it is the same thing like semantic search. RAG, I told you, retrieval augmentation generation. Augment means you're modifying the prompt. Retrieval, you suppose you have some company database. There is suppose you are working for a company and there are some company related documents and you want to utilize them while you are uh, giving the input to when we are giving prompt to the LLM model. So it will be having more context about the. That's where retrieval augmentation generation comes into picture. It's going to basically it's going to fetch that information from documents and the relevant information is going to be passed to the window. Relevant information will be passed to the. So what exactly happens, you will convert your document into vector, and then whatever input you are giving you will pass it, and if it is similar to that, then you will fetch that particular chunk of information as a context, and you will call it as hallucinations. Means simply sometimes model starts behaving differently, and it happens most of the many time multiple times. That's why they kept, like for example, if we talk about particularly about a snowflake, uh, snowflake cortex, snowflake analyst. So earlier what they used to do, simply if you'll give like a giving 5 years of sales report, and there are some different columns, so it will try to get the result, but it might be wrong. Hallucination, it will think okay it's right. That's where they introduce semantic models or semantic tables or views. Grounding, I don't know. Structured output, yeah, I know it. Function tool calling, I know it. Agents, I know. Agents basically where you want to build a complex workflow, or maybe you want to perform some operations, not just uh, a single like just giving prompt and all. Okay. Especially understand text tokens, embedding, vector representation, similarity search, relevant context, LLM answer. What is similarity search? I forgot it. Sorry. What is similarity? Is anyone watching? Let me check. Dun, 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 dun. I have 2 hours, 10 minutes. I need to finish most of the thing. I'm the one. Dun, 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 dun. Why it looks like I have 2 hours, 10 minutes. I need to finish most of the thing. Bro, it's not in full screen? Crazy. I'm the one. Dun, dun, dun. What I was sharing. Live stream work. I think now it will be better. Better. Let me check once. I think now it will be better. Better. Perfect. Let me check once. Okay. So next part, quickly. I don't think I need to go through the Snowflake AI functions again first, because those are the things that we can learn later. So let's do one thing. I was going through something. Similarity search or vector search is a technique used to find items in a large data set that are alike based on their meanings or features relying on vector embeddings and distance metrics, unlike traditional. How it works? Embeddings. Machine learning models convert data text into image, text imaging. Oh, okay. List into numbers called vectors, vector space. These numbers are act as a coordinates in massive multidimensional space where items with similar meanings sit closer together. Okay, close together. Sorry. Distance matrix. Mathematical formula measures how close points are to decide if they match. Common metrics include cosine similarity, measures angle between. Okay, that's fucking crazy. So you are calling it a similarity search. Cosine similarity. I know cosine similarity. There we basically you are angle between two vectors. If it is smaller, then they are very similar. Euclidean distance measure the straight line distance between points, often used for image or physical data. Dot product multiplies matching coordinates to case overall alignment. If you would like I can explain how to use tools like Pinecone, FAISS for this more detail on vector embedding. Let me know what you want to explore next. Nothing. Just I wanted to know the basics. Similarity search. So similarity search and sorry, vector similarity and similarity search both look same. Cortex AI functions, AI SQL, you can say. Duration 1 week. This is where I would start hands-on Cortex work. So work Snowflake provides Cortex AI capabilities through SQL and Python, including functions for tasks such as completion, extraction, summarization, translation, and embedding. So AI complete. Learn first. Text generation. AI complete. Understand prompting, model selection, structured output, conversation inputs, document inputs. AI can AI complete can also process documents such as PDF and Word files. Learn AI classify, AI filter, extract, aggregate, AI sentiment, AI summarize, translate. Embeddings. Understand text embeddings, embedding models, vector similarity, cosine similarity, storing embeddings, querying embeddings. So they have introduced another field that is vector, I believe. So there you can store this. Query layer on top. This project will teach you much more than simply memorizing Cortex function. Okay, got it. Phase 3 Cortex search plus RAG. Duration 1 2. This is a critical phase. If you want to work professionally with Cortex, you should become very comfortable with Cortex search. Cortex search provide low latency search over Snowflake data and is designed for retrieval workload including RAG. I want one thing first. Here I cannot use company provided laptop. There I can do, but they block most of the things. So how to use Snowflake Cortex in trial version. To data Snowflake AI Cortex analyst on Snowflake beginner to expert guide.
Hello friends, welcome to Algo Chat. So this is our video on Cortex Analyst, and in this video you will learn how to make Cortex Analyst from scratch. So I hope like there must be some questions in your mind about what is Cortex Analyst and how to make it, how to build it, and why it is important to learn to make such analysts. Okay, so in this video we will cover all the things. First, we will start with building a base, like what is Cortex Analyst and why it is important, and then we will start building Cortex Analyst. So basically, Cortex Analyst is nothing but it is an agent which will help you to interact with the data with natural language. Okay, so you will use natural language to interact with the analyst, and then the analyst will go to the data or the semantic model, and it will fetch the relevant data which you asked in the query, and then it will provide you the results. Okay, so let's start with what is Cortex Analyst first. Okay, so Cortex Analyst is nothing but it's a service provided by Snowflake. So this video is dedicated on the service provided by Snowflake. So on Snowflake, there is one feature in AI Studio named as Cortex Analyst, and it is a tool which enables user to ask questions in plain English and get accurate answer with SQL queries. Okay, so it is nothing but a tool, or you can say analyst, which enables the user to ask question in natural language, and then it will go to the semantic model and then fetch the relevant and accurate answers.
Are you going to?
Okay, so this service uses the semantic model to understand the business and the context and everything about the data. So first you have to make a semantic model and then integrate that semantic model with Cortex Analyst. Then this Cortex Analyst will use the semantic model to answer your questions. Okay, Cortex Analyst also operates via REST API and which will enable integration to Slack, Teams, and Streamlit as well.
Cortex Analyst operates via REST API, enabling easy integration into chat interface, Slack, Teams, or custom apps.
So you can use or you can deploy your analyst on Streamlit. So I will teach you that as well. Or like if the video will get longer, then I will make another video. Okay. Yeah. So this use REST APIs which will enable easy integration into chat interface like Slack, Teams, or custom apps. Okay. So this analyst will empower non-technical users to interact with the data. So it's very easy. So like for example, we are using ChatGPT now and it's part of our day-to-day life. Okay. ChatGPT then Copilot. Okay. So in similar way, it is very easy to interact with an agent, and we can provide an interface using Streamlit so that the users can just type their query in natural language and then they can get the answers. So it will enable non-technical users with self-service analytics. Okay, and it will also help in maintaining the high accuracy and governance. Okay, so this is all about Cortex Analyst. So now we are just building a base, building a theory, like what is Cortex Analyst and why it is important, and then we will move on to hands-on. So next is why Cortex Analyst matters. So this is what I explained in the previous slide as well. It will empower non-technical users. Okay, it will empower non-technical users to interact using natural language without any need of technical skills. So your users will be mostly on sales, mostly the functional person. They will have less understanding of the technical thing. So that's why it will enable non-technical user to use their natural language and without any need of technical skill to interact and get the insights. And that will use in decision making. Okay, so as of now, what is the practice we follow in offices? Like the stakeholder will reach out to you as a data analyst or like as a data scientist, then they will have some problem statement and then you will provide some results. So it will take some time. Okay, so it will making a Cortex Analyst and deploying it will make the decision making faster. So it will enable faster insights by reducing the bottleneck and accelerate access to critical data in dynamic environment. Yeah, so this will fasten up the decision making. Then it will also ensure the data governance. It will maintain query accuracy and compliance by enforcing semantic model and verified query pattern. It will also support diverse use case. Okay, so like it will facilitate executive dashboards, then customer service analytics and product management without SQL knowledge. So as of now, the major analytics is captured by either W or Power BI, and on the dashboards, what the stakeholders are getting is the analyst is showing them something, let's say 10, 15 KPIs, and the stakeholders are able to see those KPIs only, which the analyst want to show. But now this is not the case. There may be some questions, there may be some spontaneous question to the stakeholders in their mind that they may ask to you if you are present there. Okay, अगर आप वहाँ होते तो stakeholder आपको directly पूछ सकते थे कुछ problems या कुछ उनके दिमाग में जो क्वेश्चन आ रहे हैं वो डायरेक्टली आपको पूछ सकते थे, बट as you are not available there because of some like geographical locations. Okay, let's say stakeholder is working in US and you are working in Indian time zone, so there may be some differences. So अगर आप वहाँ होते तो he may ask you directly how question to propose.
Perfect.
Hello friends, welcome to part 2 of Cortex Analyst. So we have decided to break down a complete video in the parts because the video is getting too long and it will be difficult for you to grasp the concept. So I want you to learn slowly and understand the steps. So that's why we decided to move part wise. Okay, so this is a Snowflake page. So as Cortex Analyst is a service provided by Snowflake, so we have to create one account. So we will create one trial account, and the link for this page I will provide you in the description. So you can go into the description and then you can just use that link, and then you can create your free trial account. So it will be your 120 days free trial account on which we will make our Cortex Analyst, and you can also make one and learn how to make a Cortex Analyst, and then you can go for a paid version of the analyst if you liked it. Okay, so we can for now we can use the trial account. And also if you are working somewhere and you are a customer of Snowflake and you are using Snowflake as a data historian, then you can also use that work email. So as of now, we will start making this Cortex Analyst by creating a free trial account. So let's create a trial account. So in the work email, you can provide your personal email, and then you can use personal learning and development in your while signing up. Company name, you can like a college name. Job title, I will become data analyst. We will just click the by default setting. I will agree and we get started. So next will be my preferred language will be Python SQL. So I will use Snowflake to build I think for almost all the cases. So check all the boxes and then submit. So now you will get a email in your inbox of the email which you provided.
Back to the screen where I was first. Okay, let's do it.
To email, it will redirect you just for 120 Snowflake account ready. Okay, so we moved from here just to practice, and on this we will build. Okay, ready. Okay, so I will skip. So now you have your fit started ready, and where you can practice for 120 days. Okay, so I will skip this for now. Yeah. So you have your Snowflake account ready. Okay, so we moved from here to our Snowflake account. Okay, so this is how you will create a free trial account on Snowflake just to practice, and on this we will build our Cortex analyst. I hope this is clear to you. If you face an issue, you can use comment section and then let me know. So we have done nothing here. We have just used the link which I will provide in the description, so you can use that link.
I
Then
will
you
provide you a
can,
link as well.
you will visit this page. Then you can
If anyone
just
is-
fill the form, and you will get a confirmation mail link to activate in your inbox. Then if you will click that link, and it will redirect you to set your username and then passwords. Then after completing those, you will redirect to your free trial account. Clear? Yep. So see you in next video. There we will start creating database. Okay. Hello friends, welcome to Elgo Chat. So this is our part 3 of building Cortex Analyst, and we have completed part 1 and part 2. In part 1, we discussed the theory and built a base that was Cortex Analyst and why it is important and why it is used. And in part 2, we created a trial account and reach this user interface. So we have to create a user and SQL worksheet.
What?
So here we have selected create user and SQL worksheet and remove the by default code. Okay, and then we will first start by using the system admin role. So to switch to system admin role, we will write one query. So use role system admin, yes. And I will run this. Yes, so it's executed successfully, and our roles should be changed to system admin. Then
Okay.
I will create a database which we will use for our Cortex analyst. So as of now, this is a free trial account, so it is not having any data. So if you are working on some use case and you want to leverage the Cortex analyst service for your use case, so you may have the database ready. So you may not have to create the database. You can skip this part and can directly go to creation of semantic model. Okay, so yeah, for those who are following this tutorial for the training purpose, they can use this trial account and create the database on this trial account so that you can use this database to create Cortex analyst. So we will create or replace database, and we will name this database Cortex analyst tutorial. Okay, so we will run this statement. So it's created successfully. Let me refresh this, and yeah, you can see the Cortex analyst tutorial database ready here in the left side pane. Now we will use that database. So let's use
I think it
database
automatically switched to that database.
Cortex
Bro, why you kept big database name?
Cortex analyst tutorial, and then just run this third statement. Yes, and this database is having public schema, so we have to drop this public schema. Okay, so
Okay.
let me explain you the database and the schema for those who are completely new in this. So database is nothing but a top-level logical container in Snowflake
I
that
want
could schema
fast.
format stage.
Finish
So
it.
now we will drop the public schema. So Snowflake by default creates a schema named as public when you create any database. So some organizations prefer not to use this public database to reduce accidental use and broad grants. So grants are the permissions. Okay, so we can drop this if it is empty. Otherwise, we have to remove the object or keep it restricted. Okay, so we will move on with dropping this public schema. Yes, so drop schema if exist public. Oh, we have to gain this and run this line. So public is successfully dropped. Let's see. Yes, now we cannot see any public schema there. Okay. Now followed by that, the next step will be you have to create a schema for Cortex analyst. So let's create a schema. Create or replace schema
Schema.
Cortex analyst. So let this be the name Cortex analyst. So we are creating replacing the schema named as Cortex analyst because we have dropped the public schema which was built by default by Snowflake.
Hmm.
So I have to just run this command. I have to give this. So let's use this database,
Database.
and then we will create a replacer. And after this, for loading and unloading files, such as CSV, model binaries, into and from the Snowflake. So stage is an area for loading and unloading the files from or into the Snowflake. So
Okay.
stage can be external or can be managed by Snowflake. So the stage, which is managed by Snowflake, stores the file within Snowflake internal storage, and no external cloud bucket is required. Okay? And then if you are using external stage, then the external stage points to your cloud storage, for example, S3, Azure, or GSC. So their stage can be of two types. So we are using here internal Snowflake managed stage. Okay. So what we will do next step? Next step, we will create a Snowflake managed stage in the database and name it as our Cortex analyst tutorial stage. And we will use client-side encryption. So what I mean by client-side encryption? So in this client-side encryption, files are encrypted before they are uploaded to the stage. And Snowflake does not have access to the decryption key. So only clients that knows the master key can decrypt that. So this client-side encryption means all the all the access or all the encryption is done by the client side, and the client can really decrypt the file. So whenever the file is uploaded, so on the Snowflake by client side encryption, it is encrypted by the client, and the master key is present with the client himself. So Snowflake does not have access to decrypt the file. So this ensures the strong data confidentiality even with the managed stage. Okay, if you're using the Snowflake managed stage, then also you can ensure that there is a strong data confidentiality. Clear? Yes. So now we will move to creating a stage. So for that, so let's use this code to create a Snowflake managed stage. So we are
Okay, this is new thing. I never used encryption like this. Create or replace stage Cortex this. Okay, encryption type Snowflake SSE. Snowflake server side encryption. What is
using here
it?
Snowflake managed stage. So let's create this. So it will use Cortex Analyst tutorial database, and in that Cortex Analyst schema, and then Cortex Analyst model stage it will create. So we are creating a Snowflake managed stage. Yes, so it is successfully created. Now the next step will be we have to create an extra small warehouse. So for that, let's use this code to create and replace the warehouse, and the warehouse name will be Cortex Analyst tutorial warehouse. Clear? So this will create an extra small warehouse. So it's nothing but a compute engine. In Snowflake that will execute SQL. Yes, so your warehouse is successfully created. In this Cortex Analyst, you can also check we have Cortex Analyst model stage created. So we have created all the required database, warehouse, stage, and schema. So in this video, we have created 4 things. So we have created one database, which is Cortex Analyst tutorial. Next, we have created one schema by dropping the public schema. We have created one schema named as Cortex Analyst. Then we have created a stage. So see you next video. Next, we will create the tables in the database. Hello friends, welcome to Elgo Chat. So this is part 4 of Build Cortex Analyst. In part 3, we have created 4 things. First is database, named as Cortex Analyst tutorial. Second is Cortex Analyst schema. Third, we have created one stage, named as Cortex Analyst model stage created. These 4 things. Then move to part 4. So our tables here. Okay, so first let me explain you the use case. So we are building a Cortex Analyst on IPL. Okay, so in India, the Indian Premier League, which is the famous cricket league tournament, happen every year. So we will build a Cortex Analyst. So it will be a very simple and very basic Cortex Analyst, and you can, after learning this conceptually, you can build this on a large scale, and you can use your own dataset and own tables to build Cortex Analyst. But as of now, I'm using the basic use case or the basic tables, and we'll provide the basic data just to teach you and to me to understand the concept and how to build a Cortex Analyst. So let's start by creating the first table in our database. So we will create or replace table in the database Cortex Analyst tutorial. This is our database. Dot schema is Cortex Analyst. Dot the table name will be first of all we will initialize team or name IPL team. Here teams. Then in that we will define the table. So it will have team ID, which is of type number. So number here is a data type. It will have team name, where coach, emoji, and emoji symbol. Then we will insert the data into the table into the its regular which is
Bro, you are writing complete data? Wow.
coach of so now comma sellers.
Comma.
Now let's again try. Let's check. We have tables. First is IPL team. Move on and create. Now like third into this table. One.
So you create a
And get
table.
the
I
create.
just don't
What
want
is
to learn this.
Oh wait.
I just want to see the semantic model
And have
directly.
location. Then you have timestamp. Timestamp is 2025. It's a 12. List 342. Let's create the match schedule. Set the values. Yes. So let's refresh. Now you can see the match schedule. It is having 6 rows and having 4 columns. So now we have created the 3 table. So in this video, we have created 3 tables, which is IPL team, match location, and match schedule. Here I have done which is 1, 2 row, which is location ID 4, Bangalore, pitch 5. So keep this in mind. Yeah. So I think this is it for this video. Here we have created 3 tables, and then the next video we will create semantic model on top of the 3 table. So this is what we have in our database, which is 3 tables. So this is we have created. But if you're using on some industry use cases, then you may have some different table already present in your CV. Hello friends, welcome to Elgo Chat. This is our part 5 of Build Cortex Analyst playlist. We have completed 4 parts. In previous part, I have created 3 tables: IPL team, match location, and match schedule.
Build
And in this
Cortex
video,
Analyst
we will
on
build Cortex Analyst on Snowflake. So this video I will teach you how to build up this is location ID, which is primary key, and it should be today. Update. Let's copy from here. Cortex Analyst tutorial, Cortex Analyst, and match locations. Where location name is Bangalore. So let's write that also. Location ID. For location ID, please start making a Cortex Analyst. So what we have done here, we have created 3 tables in the database, and now using these 3 tables, or on top of these 3 tables, we'll create one Cortex Analyst. So in Snowflake, we have one Cortex AI section in AI tab. We will go there, and you will see the Cortex Analyst here. So we will try this. Now there will be no database as of now, so we have to create all this. Okay, so these are semantic views. So we have to then go to semantic model views. Then we have to create new semantic model. Create new semantic model.
What was
We
the
have to create new.
legacy?
Okay, so these are semantic views. So we have to then go to semantic model views. Then we have to create new semantic model. Create new semantic model.
Legacy, I mean they are switching to views.
We will use role as system admin, and warehouse Cortex analyst to do the
Okay.
warehouse here. Then we will use Cortex analyst to do the database. Then that we will use Cortex analyst schema,
Okay.
and then the stage will be Cortex analyst model stage. Then we will enter the name of the semantic model, which is IPL tournament. Let's give some description like this: semantic model tables and one for. So here we are getting. So here we are getting an error, the directory not enabled for stage. So before that, before proceeding to make semantic model, we have to enable the directory for stage, because by default Snowflake will make them disable. So before that, you have to make the directory enable. So for that, we will use the code snippet. Okay, we will use this code snippet. It will make the
Role sysadmin. Now you are using sysadmin only. Use database Cortex. This alter stage Cortex analyst. Set directory enable equals to true. Refresh.
directory enable for staging. Okay. Yes. Now we go to Cortex AI analyst, semantic model, then load the database, which is Cortex analyst tournament, and tables, schedule, teams, and location. So now you can see the IPL tournament file name is accepted. So earlier it was throwing error because the directory was not enabled for stage. Because the directory was not enabled for the stage, and now we have run the code snippet and we enabled the directory for the stage. Okay. Now we will click on next. Then we will select, this is optional, so we will just skip it. Then we will select the tables, Cortex analyst. We have 3 tables. We will click all the checkboxes and select all the tables. Then we will proceed next. Then here also you will select all the columns from the table, completely 11 table. Then we will read and save. If you are getting any error notification, cancel the loading and then rerun the steps which we have performed till now. Okay. So starting from this AML, going to analyst. So you have to perform the steps once again if you are getting the notification error. Although it's normal, but yeah, you can try and just. Yes. So in the second try, our model is ready.
Okay.
So now, if you come here and click down, you can see that your chat GPT type layout is ready, which is your model IPL tournament. So in the second try, our relatance. First, I have to change this. Yes. So in the second try, our model is ready. So now, if you come here and click down, you can see that your chat GPT type layout is ready, which is your model IPL tournament. IPL tournament. This is semantic model used for Cortex analyst, which is a description. Okay. Now this is your own chat GPT, which is built on top of the 3 tables which we have created. So it can be a particular use case as well. So you may have some different tables, and you will get this user interface when all the steps will execute it in correct manner. Then you will get this user interface where you can interact and give your prompts. Then ideally your model should respond you with the correct answer. So now let's check that is it working fine. Okay. Let's check for this. So remember we have given Dinesh Karthik name in the table, who is a coach of RCB. So let's check who is the coach of RCB. So I'm just interacting in natural language, and I'm expecting it should return me Dinesh Karthik. Yeah, so you can see the coach is Dinesh Karthik, and it is also running the logic behind the result. So you can see I've just entered my question in natural language, and it is returning me the answer. Now let's try with 2-3 more prompts. Who is or what is the symbol for? We have given DC. So what is the symbol for DC? Remember, we have given some symbols like ampersand, then @ like this. Yeah, you can see we have given add symbol to DC, which is digit capitals. So this is how we are interacting. And remember, like there is one very interesting part. Even if you do the typo, like for example, which team is or which team is having Moody. I'm just giving Moody as head coach. So I'm just returning it in natural language, or I'm just giving the prompt in natural language, and I'm expecting my pilot, or I'm expecting my agent to provide me correct answers. You can see which team is having Moody as head coach. You can see as such Moody Karthik. Also, it will give you suggestions. If you see here in suggestions, there will be some suggestions if you are going wrong anywhere. Okay, so it is interpreting it as Moody Karthik, and returning the results. So this is your Cortex analyst, which is built on top of the table which you have provided in the packet. Clear? So this is the way to make a Cortex analyst using Snowflake, saving a semantic model. Now in the next part, you can deploy the semantic model on Stringlit, and you can host that Stringlit app, and you can provide the access of your Stringlit app to the users. Then your users can enter the prompt here and can interact with your data and can get these results. So this is how we are building Cortex analyst on Snowflake. This is a great service which is provided by Snowflake, and I found it very interesting. And like maybe in future there will be a lot of use case of this Cortex analyst where people can not people can interact with the data within seconds. So here we are just entering. We have made, you can just clear others if you have given. So when you will have interaction between these 3 tables, then you can expect much more complex queries should get run. Hello friends, welcome to Algo Chat. This is our part 7 of the playlist Cortex Analyst. So in previous videos, we have learned how to make semantic model and then how to establish the relationships. Now in this video, we will learn how to make Stringlit app. So basically our goal is to deploy our Cortex Analyst on a Stringlit app so that we can share our Cortex Analyst and people can use it. So beforehand, I've created one Stringlit app. Let's have a look on that first. So this will be our user interface for the Cortex Analyst, which we have built in previous videos. It is starting, it's getting loaded. So yeah, this will be the user interface, Cortex Analyst, data copilot. So it will take natural language and then it will go to your semantic model and the tables, and it will return the results. So remember, we have three tables: IPL, team, match schedule, and match location. So return the result on this user interface. So basically, Streamlit app is to provide user interface to our Cortex analyst, and then we can use the Streamlit app to share and make the app accessible and make the Cortex analyst accessible to our users. So we can try this, and then I will tell you how I have made this. So one question was, who is the coach of RCB? Remember, Dinesh Karthik. It's thinking Cortex analyst is running, and it is returning the result as Dinesh Karthik. Clear? Now one more. What is the symbol of RCB? So it's at the rate. I hope it's clear. Now there is one button to clear as well. Let's try one more question. With the user interface which will come. Okay, then you can choose your database, which is a Cortex analyst. You will choose your schema, and then click run on warehouse. So we have created a warehouse, Cortex analyst tutorial warehouse, which is nothing but a compute engine. And then I will click create. So where I can code in Python language, and Streamlit is the Python library. Earlier it was open source, but now it is acquired by Snowflake. So you can use this Streamlit library to make your user interface. So as of now, in this playlist, I'm not going in that detail to make the Streamlit app using Python. So I will provide you the code of the Streamlit app, which I've made and demonstrated you. I will provide you that code in the description. Okay, so this is how you can create your Streamlit app. So here is the workspace where you can type in your Python code and make a Streamlit app. So this is also a sample Streamlit app, and also side by. So now I think this I recommend you to watch full playlist. Answer time now. So we have the take the videos, and then subscribe my channel for upcoming videos. I will bring such videos on AI in future. So please subscribe my channel
No,
and
I
like the
cannot
videos. See you.
subscribe
Bye bye.
from. Sorry, I will subscribe from other channel.
Hello YouTubers, how's it going? So today we are going to learn how to create a Cortex analyst, which is a tool in Snowflake, a part of Cortex AI ecosystem, which can write and execute SQL on top of the tables and databases to bring that data for you. Then we're going to create a Cortex agent in which we add that Cortex analyst and use this Cortex agent inside of Snowflake Intelligence to chat.
Hello friends, welcome to Elgo Chat. This is our part 7 of the playlist Cortex Analyst. So in previous videos we have learned how to make semantic. You will choose your
Oh,
schema.
it's already
and then
done. I
click run on
completed the
warehouse. So
playlist.
we have created a
To
warehouse,
be
Cortex
honest,
Analyst tutorial warehouse, which is nothing but a compute engine. And then I will click create.
Most of the information I was already aware. Only the part was most difficult.
Game in the world is
Oh, where I went? Where I went? Time 1 hour 38 minutes walk. Dataset. Let me take dataset for data analysis. I will take something cool. I mean, yeah, I just want, but shows it. I think network is also very slow. So here I will do one thing. Data sheet for data. ChatGPT, come on. Hey, here it's already open. Can you suggest me a data sheet that is publicly uh, public publicly available available for uses. I'd recommend starting with the dataset simple through Snowflake revenue time series dataset, daily routine, product team, reason team. No, I don't want to use this one, especially. TPCH. TPCH sample data directly into Snowflake through Snowflake sample data. It's an industry standard benchmark that includes multiple layers, making it much better for practicing more complex semantic models. Typical TPCH schema includes things such as customers orders, line item, part, supplier, nation, region, part, ship. Oh, where is it? Snowflake sample data. Okay, let's do one thing. If we have data, we can directly use them. Snowflake project workspaces. I will say no workspace. Workspace. Is it slow or my internet is slow? Seems like internet is okay. Only the problem is with Snowflake itself. Oh shit. Seems internet is also slow. Don't give me all the shit. Just want to create new workspace. My workspace. I will create another one. Workspace. Private workspace. Cortex. Snowflake. I'm wasting time in another Snowflake workspace. No, Cortex. I will say. Let's use this workspace. SQL file, and I will name it uh, Snowflake Analyst. Snowflake Analyst. So create. Okay. I databases. So I'll do one thing. I'll copy the tables if they are available. Snowflake Learning Database. Can you give me the full name of the tables schema? Where is it, bro? Codex Analyst demo. Is it really available? Available. Oh, it's slow. Very slow. Something is wrong here. Because is it hallucinated or what? Let me see if it is there. I think sometimes they are generating any stupid query. What? Are you giving me tutorial answering about time series revenue and okay, it's like you are giving me some data. Oh, sorry. I mean, yeah, I got it. So we need to download these files. I will do one thing. Sit, yeah. Kamesh man. Update for multi-turn. So we have three data sets. Let's do one thing. I will create my own file. Create database Cortex. Cortex. Uh, I will call it Snowflake Cortex. Cortex. Okay. Comment. I will just add a comment. Uh, DB database for learning Snowflake Cortex. Create. Oh, sorry. Drop. I will drop first. This working. Use role sys admin. I had the recommending I got. Now I'll create this. Okay. Now create schema Snowflake snow. I make lot of analyst. We are learning Snowflake analyst. Comment uh, schema for learning Snowflake uh, analyst. Show. Okay, if I will show you show databases. Okay, I have to do one thing. I don't want to use any uh, particular table or something. Not table basically. Warehouse. Okay, let's create create warehouse Snowflake uh, Cortex warehouse Cortex warehouse. I think it's better if I'll use. Why do we need to? Okay, but let's see. Keep everything generic, similar. Okay, warehouse size is equals to x small. Okay, now R2 resume true. R2 suspend 60. How to do it? So you can see it. So it will take automatically the warehouse when you are creating. So show databases. Let's see if it is working. So our warehouse is working. Show warehouses. Okay, I'm not learning anything new, bro. It's very bad. Looks good. Compute warehouse, Snowflake warehouse. Streamlit. This is for notebook, and it's they kept it standard. It's not a Snowpark optimized or something. Okay, no problem. So we got the Snowflake where we created a Snowflake warehouse schema, data and analyst schema. Under that, now the next part is we are going to create tables. Create table. What are the different things? Reason, product, daily revenue. So I hope they will give some structure for it. Create or replace table, daily revenue. So I will do this and I will copy it from here, because here from here we'll get the information. I know a few things I need to remove. Cortex and list demo we are not using, so we already selected, so we don't need to do anything. It will go under the Cortex Snowflake Cortex database and Snowflake analyst schema. So by default they are selected, so you don't need to give full path. Reason time. Okay, another one I forgot to. Okay, so all the tables are created. I will use. I know we can use copy into that command. For that, I need to create a stage, and I don't want to create a stage as of now. Let's see how it they are suggesting. Okay, so that means we need to create a stage. So let's create one stage. Okay, create stage, Snowflake stage, Cortex stage. I will say Snowflake, Snowflake, Cortex stage, and comment internal stage Snowflake internal stage for Cortex band. So for Cortex, all the default values I'm taking, because so we can see the stage. So stages, if you'll see, then you will get it. So stages, yes, you can see it's under the name database schema. So it's a schema level object, by the way. If you are set, why are you see the UI part is slow? No problem. Path. Okay, so we have Snowflake Cortex. If we'll see information schema, and we don't want public schema, add data. Let's see how it goes. Load files into stage. Okay, we can use directly. So 250 MB, up to 250 MB of file if you want more than this. But Snowflake recommends that you should keep the file smaller, not so smaller, but so that you can get the parallel loading capability you can utilize, and it's very important, very important, guys. Can I select more than one? No database selected. I will select Cortex. No, don't select public schema. Snowflake Cortex stage that we created. Upload. Okay, you can specify folder inside it. I want just upload it. Then 3 file uploaded. What is this? Okay, time to flash out. Progress work space. My name is what? Create notebook. Now it has a lot more capability. That's why it's no more Snowflake data warehouse. It's a platform, data platform. You can use notebooks. You can run Python scripts. It's more like a Databricks. They are competing with Databricks. Though architecture is different, that is running behind the Spark, but it's not. They created one Snowpark, very similar. So list @ Snowflake Cortex. I think this is the command, right? Wow, it's the same. So copy. I will use same file format. From here, I will copy. I think most of the file format we are not creating, so they are specifying all the information. But let's do one thing. Our goal is not to learn here. Uh, oh shit! You forgot. I forgot one thing. I have to update this. 10 loading 10. One thing force through. If you'll keep force through, then every time it will load the data. Copying. Holy shit! So this is done. So we got three tables. My patience is waning. Now the next part is we need to perform analysis. And first way I will do it's simply we have tables and the way he told. But to be honest, I want to try out the building the semantic model and then working manually building the semantic models. So here is the AI Cortex Studio, and they kept multiple things. So AI Studio, agents, AI functions, and list, and search evolutions, co-work. So much set I created it on search analyst. Wait a minute. Wait a minute. Why are you asking for me to select the YML file? Isn't there another way? I know there was semantic model, build a semantic model, and on top of that run the queries. Queries. Oof, 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 oof. Holy moly shit. Is it slow? Why it is slow? I have to start 1 hour 80 minutes left. I want to do much more. I'll take break till then. Transition, not transition break. I won't take 15 minutes, but I'm Okay, so back again. Intro, live stream. Okay, okay. Cool down. Pancho, this one is not working. Let me just click. Oh, okay. Oh, thanks. It started working. Semantic models convert to semantic view. I think they are promoting semantic views. Convert to semantic view. Support for semantic model will end soon. Convert your semantic model to semantic view to convert an individual. Okay, let me go to semantic view. Search Snowflake Cortex, Snowflake Analyst. Create first semantic view. Create semantic view. Hey, he used something else, bro. Let me see. SQL queries. Select warehouse, compute warehouse. No. No. Compute warehouse. Okay, let's see here how they are creating. Answer question, create a Streamlit app to talk to your data through Cortex. But where you created Cortex, you created just tables. Fuck. YML. Okay. Okay, great. Here you are providing all the information. Information. This is okay, but where is the YML file? I don't know. Improve the accuracy of Cement by uploading SQL queries or Tableau source file. No, I don't want to do that. So let's say, okay, one thing I'll do, upload CSV file with SQL queries or select CSV file with queries. What he did? History.
Hello friends, welcome to Hello Chat. This is our part 5 of yes, 4 and location. So now you can see the IPL tournament 5 game is accepted. So earlier it was throwing error because it directed semantic model, create new semantic model, then again select the system admin, select the warehouse,
Back. Semantic model let you explore your data using plain language. However, we now recommend using semantic view instead of better way to define business logic and metrics. If you expect to uh, provide context. Okay, I am just skipping that part. So enter name, semantic view. What I clicked? Semantic, create semantic model legacy. Skip, skip. Name. Uh, what was the name of it? Let's say Cortex Analyst demo. No, I will call it revenue. Revenue. Oh, it's like revenue generator queries. Snowflake analyst. Okay. Select tables. Three tables. Select all. I'll select all. Okay. Columns. Select all. I'm just selecting all the columns. As of now, I'm not aware, to be honest, how to utilize it better. Oh, okay. Finally, I created one stupid model. Take up to 10 minutes, please. Logical tables 3. Open playground, add verified queries. Explain the dataset. Just looking what exactly it's going to do. This dataset tracks daily revenue performance across product and regions. Here are what you can explore. Daily financial metrics, actual revenue cost, goods sold, GCS, products, regions. The kind of questions you can answer, how is actual revenue and this blah blah blah. So done, can be done using it, but I don't want to that create a streamlet. Okay, then recommended when. So let's see what are the questions. What was the total revenue last year? Let's see what was the total revenue last year. So it's suggesting some. This is the request ID you can get. This is our interpretation of your question. So first it's giving, this is cool thing. It's not just blindly giving the result. What was the total revenue for the previous calendar year? So year 2025. Not if you made the past 365 days instead of calendar year. Please ask for past. Oh, wonderful. Total revenue null. Legacy query. Sorry, logical query. It's giving some revenue, total revenue from daily revenue, where date trunk, year, current date, year minus one. So last year dated, so you did, then you are date trunk using, and you are getting the year and date is column, year greater than equals to this, and date trunk, year less than current date. So current date, it's less than this. So basically you are getting for the last 1 year only. But why don't you do then date equals to instead of this? So you will get the last year only. Okay. So seems like model names Cloud Sonnet 06 is semantic model SQL file internal because clear SQL analyst orchestration path regular SQL chain. So this is the kind of response that we are getting from the LLM model or what? Cloud tool calling or something. Okay. Another we can call which product line generated the most revenue. Let's see, because now you can see here we are not directly calling product dim daily revenue. So here we need to join revenue with product. This is our which product line generated most revenue in the previous year. I think you will get null only. What? Oh, wonderful. This is a cool thing. You generated something, but right now you haven't provided the proper semantic model. You just created a blind blend model based on the tables and all. You haven't edit YML. Let's see how it's going to work. So database base table. Okay. Okay, so this way we are creating YML uh, semantic model. So which one is better? I think this one will be better compared to the model that we are creating using the SQL. So revenue queries, tables. So you are describing table daily revenue. The table contains, okay. So base table, you just provided Snowflake data daily revenue. Base table dimensions, you provided dimensions, and relationships you haven't provided. So that's why. Okay, let me ask ChatGPT only itself. This is the auto generated YML. Can you fix it and add relationships as well? Add primary key, reason name, daily revenue product name. Okay, add the two relationship product to product name, daily revenue to product name, and daily revenue to reason. Yeah, I was thinking like it's already taken care. Description, fact tables, it's clean and more readable. Wow, wonderful. Okay, so it's great. Actually, I was thinking that I need to create a SQL way. There is another way where we are writing like okay dimensions is in the form of SQL. But nowadays we are switching. Our people are. It's better to understand when we are. Yeah. So here daily revenue to product name. So now relationships are there. Okay. Now again I will call. I will ask the same query. What was it? Wow, not something completely different thing, but it's better, very better, very good compared to what I was thinking. So exploration is very important, guys. Where are the questions I wanted to? Which product line generated the most revenue? So I'm just curious. In this way, we are creating okay clothing. See, now it's generating query. It knows how to deal with, and that's where semantic models or views plays a key role. Because here what they do, simply you are providing everything. You are giving context to the Cortex analyst, or you are giving context to the LLM model, like okay this is the tool, these are the relationships, and these are the dimension table, these are the fact table, and what is the description for each. So that yeah, because if you know one thing, like LLM model completely relies on the context that you are providing. If you are not providing rich context, then it will give you hallucinated result. That's where context comes into picture. So logical query, what is physical query, by the way? Looks something. A standard executable SQL statement that references concrete tables, columns, and functions in Snowflake. Logical queries ultimately resolve this form before execution. Okay, got it. So here you are getting logical query that's not going to be executed in Snowflake if you run it. Okay, wonderful. So daily revenue you are joining it with this, and you are getting the value. Perfect. Okay, I will uh, show revenue by state. Perfect. Oh, sorry. User Cortex list. This is our interpretation of your question. This is cool thing. It shows first interpretation. It shows result, and you can verify it. Where is India? Hello, my India. But the numbers are same. No, not same. हाँ सुनो सुनो बोलेंगे hello, my India. Okay, okay. So Cortex analyst part is done. I have a couple of queries, so I will ask it here in a voice mode. Hey ZPD, I have a couple of queries. I'm just exploring Cortex Analyst and found few different type of queries that are coming into my mind. First one is, what's the difference between semantic models and semantic views? Now I can see like in the user interface they are recommending to switch to semantic models and not semantic models but semantic views, and they are recommending that you should transitions from semantic models to semantic view and or migrate them because now semantic model are legacy. So first thing, so I'm not sure what is the difference between these two. And second thing that is coming into my mind, I have seen in the past in a tutorial where they were building the semantic model using the uh, SQL, where they were defining relationships, dimensions, facts, description, and so on. But when I used simply Cortex Studio or Cortex Analyst, and there I just selected the list of tables that I wanted to use for the analysis, and I haven't provided any query, just skip that option, and it created one YML file. So what's the real use of the YML? Are we defining the context in that YML? Is it similar to the Cloud skill.md or maybe skills, and there we are creating plenty of files? So what exactly it is doing? Can you briefly describe about it? And also I want to know, if YML is the source of it, can we upload some I have a couple of queries related to it. For example, suppose we have uh, thousands of tables, and don't you think it will be a very complex semantic view, and we wanted to build a Cortex analyst system. And also one more thing, suppose this is suppose you have a warehouse, and okay, I'll do it in second part because otherwise it will be too much context for you. Yes, your question are actually getting to the core architecture of Cortex Analyst. I will separate the concept because there are three things that can easily get mixed together: legacy semantic model, semantic views, and YML. Semantic models versus semantic view. The simplest way to think about it is semantic model, the old way of giving Cortex Analyst business context. Okay, semantic views, the newer native Snowflake objects that stores the business context. Historically, Cortex Analyst used YML file stored on Snowflake stage. The YML describe things like tables, dimensions, fact, metrics, relationships, descriptions, verified queries, instructions. Cortex Analyst would read the YML as a context when generating SQL. Snowflake now calls that the legacy stage-based semantic model. Okay, it still works for backward compatibility, but Snowflake recommends semantic views for new implementation. New architecture is physical tables. Physical tables, on top of that, you are creating semantic views. Cortex Analyst is going to use semantic views, generate SQL, physical tables, okay, And a semantic view itself is a schema level Snowflake object, meaning Snowflake can manage it like other database object with privileges, show, describe, sharing governance, etc. Okay, then why am I still seeing YML? This is part of initially feels this is part that initially feels confusing. YML isn't semantic view itself. Think of YML as declarative definition or configuration for semantic view. For example, you can write table this, and Snowflake can use the YML to create an automatic semantic view. Snowflake explicitly supports creating semantic view from YML, including through the Snowset Cortex Analyst Editor. So yeah, this is cool thing, but I got the real meaning of analyst Cortex. What we say? Cortex, not Cortex. Semantic views, semantic models. The semantic model, old approach where we were defining YML, and every time when we were querying, it's going to refer that YML file, and then it's going to, based on that, it's going to generate the query. But now there was problem like you were storing it in the into the stage in a stage, and you don't have governance or you don't have full capability. Now they are calling views because it is on top of the your tables or views. So okay, now I got it, makes sense. And yes, the YML is basically defining the context. You are absolutely on the right track here, but I would make one distinction. It is merely context. It is structured business semantic plus context. Suppose your physical table contains date, product, this. A normal LLM looking at this might know what revenue means, but it revenue, a profit, sales region. How should revenue be aggregated? The semantic definition tells it. Name, total revenue, expression, sum revenue. Now you are effectively saying when user talks about total revenue, sum. Okay, matrices. Yeah, we are calling them matrices. You are telling analyst these two logical entities are related through product ID. Actually useful, but not exactly the same. You are analyzing is this similar to skill.m? Yes, but technically no. Skill.m might tell AI assent. Hey, here is your our business world. Customer means this. What happened when you selected table in Cortex Studio? This is actually a really nice feature. Uh, essentially told you essentially told Cortex analyst they there are tables I want you to work with. You didn't manually define the semantic layer. So what's the actual life cycle? Think about the revenue example. Physical data. Step to business semantics. What is the meaning of semantics? I'll ask it. Very much. Yeah, absolutely. You should not put thousands of table into one Cortex analyst semantic view. That would become nightmare. One gigantic semantic model Cortex analyst. You would have thousands of columns, hundreds, thousands of relationship, overlapping business terminology, enormous metadata, ambiguous metrics, potentially conflicting definitions. The semantic layer should generally represent a focused business domain, not your entire enterprise database. Sales, finance, HR, semantic view, analyst. Semantic view to IML. Okay. Shafish Sagar, someone recommended me. I will copy paste here. Mental model I would keep. If you are learning Cortex Analyst, remember this: physical data, semantic view you created, Cortex Analyst, natural language question, generated SQL query result, and how I define, deploy semantic views. I have one more query. What exactly happening behind the scene, or when we call it Cortex Analyst, what exactly is running behind it? What First I will tell you my understanding about it. So, semantic view is acting as a basically semantic view acts as a context for the LLM model. So whatever query that we are giving to LLM model, it will go along with semantic view to the LLM model, and then LLM model is going to interpret, and based on it, it will provide the query to the Cortex Analyst. And I think Cortex Analyst is act as an agent between LLM model and user, and it's going to interpret the response from LLM, and maybe it will generate the query, or maybe it will call another tool that is going to generate the query from LLM response, and it will return, and it will also run the query, so that you will get the result as well as the query. So just let me know if my understanding is correct, or uh, some like in between there is some piece missing. Set. Hello, Parth. User LLM semantic view. LLM understands question. Very close but change. User Cortex analyst. Natural language question. It's SQL result to user. Cortex analyst you are calling full box. Semantic view business semantics queues to information to SQL. So the important thing is Cortex Analyst is managed service or orchestration layer around the SQL generation process. Snowflake's API describes the analyst endpoint as taking a user question plus a semantic model view and generating SQL. The response can contain the generated SQL and analyst response. What exactly does the semantic view do? Let's use your example. What are the selling? Sabzi, vegetables, or something else. What exactly does these semantic view do? Let's use your example. Your semantic view says daily when you product them. I'm reading something. Relationships uh, matrix. Okay. Now you ask what is the LLM doesn't have to figure out entire database schema from scratch. The semantic layer gives it the conceptual word. Then where does the LLM come? Doesn't expose a simple public diagram for every internal component. So we shouldn't pretend we know exact internal prompt tool chain, but conceptually, Cortex analysts need an LLM. Oh, bancho. I don't know what are they building Taj Mahal or something. It's been long time, bro. They are doing still the same. But conceptually, Codex Analyst need an LLM-driven SQL generation process. It takes something like user question, semantic view, conversation take context, instructions, potential verified queries. This is where has the routine routing mode, which automatically applies when Codex Analyst generates from a semantic view. Immediately thinking of this. What does it lead to? The semantic layer then supplies the governed definitions of those metrics, joins, dimension, etc. Let's explore. So this is one way. Let's see how to create Cortex. Snowflake Cortex, Snowflake Analyst, revenue queries. Is it view or what? Oh, so I think I created uh, Snowflake Cortex Analyst. Back there was okay. I will do one thing. Cancel it. Struggling urban learning use SQL detailed creation rather than only relying on UI generated YML. Snowflake supports both approaches and both create the same native semantic view object. First, learn the first basic syntax. Core. Create our replace semantic view name. Okay, this is cool thing. What are the different things? Notes, where is notes? So create or replace semantic view. Okay, view name. Perfect. Tables. Then you are providing facts, dimensions, matrices, and relationships. Let's create Snowflake revenue analytics. Seems like I provided it. What? Somewhere I provided something. Snowflake Cortex system. Yeah, that's why it's providing me the full name. Semantic view, Snowflake got a Snowflake analyst, revenue analytics. So it's in the name of it, table. You're calling daily revenue as daily revenue. Revenue performance by product, region, and date. Product dimension, product. Okay. Tables. You are giving base tables. Product dim, product and product line information. What is product line information? Region dim, region this. Prime. So basically, you are calling this as a complete tables object, and it contains some different objects and their information. For a particular object, what is the primary key comment? Facts daily revenue dot revenue. So okay, as revenue. First, let's see. Then I am providing metrics. What are the different metrics? Total revenue. If total actual revenue, you got the like this. Sorry, Shan even was in. No, not at all. No one is interested in what we say. So add relationships. Okay, so you haven't added it hasn't added the relationships. So one more block will be there. Should be daily revenue to product name daily. So it could be one to many to one. Okay. So in current semantic detail definition, define the relationship with Snowflake uses primary a unique key to understand the relationship cardinality. The complete relationship section is completely conceptually the complete relationship section is conceptually like this. So daily revenue to product dim, you are giving the name for a relationship. Daily revenue product ID references product dim. Okay, Snowflake before you paste this syntax, I would recommend checking the generated detail from your Snowflake account, because the current detailgram has evolved. The Snowflake's documentation has several. and view grammar or generated one in a Snowflake and run. There is something even more interesting. Why you don't actually have to think of this as YML to semantic view. You have now you now have two first authoring methods. Semantic view uh, both produces the same native semantic view object. Detail SQL semantic view, YML specification semantic view, and you can go the other direction. Querying the semantic. Once it is created, you don't necessarily query the physical tables directory. You can query the semantic view using semantic view. The mental model, physical table, YML or SQL, you are generating the semantic view, and then from semantic view you can say you are providing in semantic view metrics, dimensions, relationship, Cortex analyst, natural language, SQL query result. I don't know, but I feel like okay, I take break now. I'll stop streaming. I thought I will do it for sit when I did this. Okay, thank you so much. I'll see you in another 1.5 hour.